All right.
Just put both.
Yeah.
Part 1, part 2.
Yeah, that's true. I could do that. All right. Cool. So all this is going to come back Wednesday when we solve equations. But I'm just showing you the absolute value function can be written as 2 lines put together. Okay? Okay. All right, let's talk domain. Domain is the set of all x values. When you read domain from left to right. So I'm looking from left to right when I look at domain. Okay? And when I look for range, that is read bottom to top. Okay? Range is your y values. Domain is your x values. Okay? So let's give domain, I'm going to give it in both interval and set builder notation. So if you look only at this function left to right, so take height out of the picture here. And I imagine this is just a number line, like we were doing on Friday. Imagine this is just a number line. What would that number line look like? Yeah, negative infinity to infinity, right? That's what the domain is. So our domain is parentheses negative infinity to positive infinity, or we could say all real numbers. Both of those things mean the same thing. Okay? So for the range, I'm looking at the y's. I'm looking bottom to top. So if you were to take out left to right, and you were to look only vertically, like smush these along the y-axis, right? Imagine you could do that so you have a vertical number line. Where would that number line start?
0.
At 0, and it would go up. So it would be 0 to infinity. So, but we hit 0, right? We have that point, so it would be bracket 0, comma, infinity. Or in set builder notation, the set of all y's such that y is greater than or equal to 0.
Why is that a bracket?
It's a bracket. So this is interval notation, and it's a bracket because brackets are inclusive. So I do reach the point 0. I do have a y value of 0. Okay? If I have that, then I get a bracket is inclusive, a parentheses is non-inclusive. You could never reach infinity. That's why infinities always get parentheses. Okay. This is our friend the parent function. Now we're going to move it. We're going to transform it. Okay? First, we're going to write down any function's transformation form, and it looks like this. A times f of x minus h plus k. Y'all remember seeing that? Maybe for quadratics?
Probably.
Yeah, I remember.
Okay, I'm just going to show you this real quick. Alright, I'm going to go, alright, so from Algebra 1, you all looked at this with a quadratic, right? Remember that guy? Alright, so this is general transformation form. Look what happens to our quadratic as I change A. What do you call this? Vertical stretch. This, whoops, hold on. That is a vertical compression. When A is less than 1, vertical compression.
I was like, how do you
Vertical
compress
compression.
Like you're taking it vertically and going, and it's going to go, you know? Yes. It's getting wider, okay? All right. But what about when A is negative? What does that do? It's a reflection across the x-axis, right? Let me put A back to 1 here. Okay. All right. What does H do?
Moves it left and right.
Moves it left to right. See, horizontal translation. Now notice there's a minus sign in the transformation form, okay? That's going to come up again later, okay? And then if I look at K, vertical translation, right? Okay. Now, if I change my parent function, I'm going to change that to our absolute value. Oh, Lord, what did I just do? Whoa, that is very interesting. Okay, there we go. Now I'm going to change A. Oh, look, it does the same thing, except instead of like the curve or the quadratic, we just have 2 lines. So it's affecting the slope of them, right? So when A is less than 1, we have a less steep slope. We still reflect. We can shift left and right. We can shift up and down, right?
Yeah.
All right, so all those same things are going to happen here for our absolute value function. So specifically, what that looks like for absolute value is it looks like this. Y equals A times the absolute value of x minus h plus k. Okay. So A is your vertical stretch or your vertical compressions. And specifically for absolute value, that's affecting the slope because we have 2 lines. So that specifically changes the slope. And when A is negative, that's a reflection over the x-axis. Okay. And then your H is your horizontal shift. Moves left to right, right? Okay. However, when you have, because it's got a minus sign in the transformation form, that means that it's going to move, the value of H is going to move your function opposite to what would make sense. So for instance, if you have parenthesis or absolute value of x minus h, that's going to shift to the right. And if you see absolute value of x plus h, that's going to be a shift left. Do y'all remember that h was opposite? All right, resume. Okay. Now that we won't remember that, but K is okay, all right? K is okay. So that is your vertical shift, and this one makes complete sense. Okay, if you see a plus K, that's a shift up, and a minus K is a shift down. Okay? K is okay, it won't lie, but H lies. What you see as H is opposite to what it looks like in the equation. Okay? So what we're going to do now is we are going to create transformed graphs in this form. And we're going to do that by hand without using calculator. Okay? So let's open this up. All right. I'm going to show you how this goes. Now I'm going to tell you right now this is going to be like 80% of the rest of this class. All we do is we study functions. When we study a new function, we transform it. So you learn transformations once, you carry it with you all year. Okay, so first I have to decide, when I see a function to graph, where am I going to put the first point? Okay, now when you make a graph of an absolute value function, the vertex is going to be your first point. That is a grounding, that is going to be your grounding point. Okay, so on the parent function, that vertex is at 0, 0. So if I have a transformation that shifts up, down, left, right, what shifts is going to be the vertex. Okay? You could probably tell that when I was doing the sliders. Okay, so if I look here, what is this equation telling me how to shift? What is that plus 3 on the inside? Left 3, because it's a lying H, right? It looks like it should be right because plus, but no, it's going to go left 3. And this minus 4 means it's going to go down 4. So when my vertex is normally at 0, 0, I'm going to move it to the left 3 and down 4. And that's my vertex. Bless you. Now how do I make the rest of the graph? Well, if I don't have any kind of vertical stretch or compression, I just graph these slopes. But instead of x being greater than or equal to 0, I'm going to do it from the left and right of the vertex. So my slope will be 1 and negative 1. So from here to the right, I graph a slope of 1, up 1, right 1. And on the left side, a slope of negative 1, because you want it to get that V shape, right? always the same slope unless it's stretched or compressed. And in example 2, we have one that's stretched or compressed.
There's a kid that I went to middle school. He looked like he was compressed.
Thank you for that.
He was like really tiny and like really like chubby, so he was like.
Okay.
Sorry.
If that's what it takes for you to remember it, that's great. Okay, let's give some characteristics. Let's give the domain. Okay, I'm going to give the domain. I'm going to do interval notation. What do you think the domain's going to be? Do you think that will ever change for this function?
No.
I can't flip that, stretch that, compress that in any way that's going to keep it going from the left into the right forever. So that's your freebie points. Domain is all real numbers or negative infinity to infinity. However, your range is going to change depending on where your vertex is, right? So it might be helpful to label your vertex when you're first starting to do this. This vertex is -3, -4. So the range, the very bottom is -4, and it's going up to infinity, right? So our range would be bracket -4 to infinity. So when we consider so with these functions, we either consider the vertex to be a maximum or a minimum. Like, common sense tells you that's what? A minimum, because it's the bottom, right? So this one has a minimum, so I'm going to write min. And if I ask you what is the min or max, you give the y coordinate of the vertex. So if I say, what's the minimum? The minimum here would be just -4. Okay? And if it was reflected, it would have a max, right? It would have a top. Okay. Questions about this one? All right, let's look at example 2, right? Okay, so we got a 3 in front of our absolute value, and that is an A. It's a vertical stretch. A vertical stretch of 3. So I'm going to write vertical stretch times 3. And what that means, what this 3 means is that, how can I write this? You're going to triple the y values. That's how you achieve a vertical stretch, because y is the vertical coordinate. So all of your y values, like in this table, would be tripled. So you'd have 0, 0, 1, 3, 2, 6, 3, 9, right? But absolute value is made up of 2 lines, right? So another way that we can see our vertical stretch and compression, just for this function only, is to see this A value as the slope. Okay? So we are not shifted anywhere, so our vertex is still at 0, 0. We can either look at it as tripling the y values or a slope of 3 on the right side and a slope of -3 on the left. So up 1, 2, 3, right 1. And to achieve that V, we would go up 3, left 1 on the other side. Okay. Notice I'm filling my graph, all the space that I have for this graph, filling that up. Is everyone okay with where we got these points to graph? Okay. Domain, I'm going to do that in the other notation, all real numbers. Range would be from 0 to infinity. Does this one have a max or a min? Min? And what is the minimum? 0. The y coordinate of the vertex. Okay? All right, so if you are to graph with transformation form, you are looking at the numbers in the equation and figuring out, is it an A, H, or K? and graphing appropriately. Right. However, sometimes you get things that look like example 3. What is weird about that one?
The 4 is inside the absolute value.
Yes, the 4 coefficient on x. Okay? So when you see these, it's not so clear how to make the graph. It's only clear when you have transformation form. So what you can do is you generate what's called an equivalent equation. That's what EE means. Okay? Which means we're going to rewrite this so it's graphable. Okay? And so we decided that the only thing that's wrong with this is that 4, that coefficient on x. So what we can do is we can rewrite this. We can factor out the coefficient on x. So I'm going to pull it out. So if I pull out the 4, it'll look like that. I'm going to factor out a 4. What's 4x divided by 4? X. 1x, or just x, right? And then negative 4 divided by 4 is negative 1. Okay, so would you agree that this expression in the absolute value is the same as the other one?
Yeah.
I like reverse distributed a 4, basically, right? Okay, now here's why I want to do that. Now I have a product inside the absolute value. I have the absolute value of 4 times x minus 1. So when I have a product, I can split this up. I can take the absolute value of each. So I can say that's the absolute value of 4 times the absolute value of x minus 1. And the only reason I can do that is because of a product, right? Like, for instance, let's just make sure we all understand why. If I said absolute value of 6 is the same thing as the absolute value of 2 times the absolute value of 3. Is that true?
Yes.
Yeah. So I'm just using that logic here. Okay? All right, now what is the absolute value of 4?
4.
Yeah, it's 4. So equivalently, I have an equivalent equation of f of x, can't forget the f of x, is equal to 4 times the absolute value of x minus 1. It's the exact same equation written in a way that's easy for me to graph it. Okay? So to graph it, I would move, how would my vertex be shifted? Left 1, and then we have a vertical stretch of 4.
Shouldn't it be right 1?
Right 1. I forgot she lies, or he, right? Either one. Both. They're all liars. Okay, right 1. Thank you. Right 1. And a vertical stretch of 4 means a slope of 4. So up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. There we go. Yeah, to the right 1. Okay. So you got to take something that doesn't look graphable, rewrite it so that it is graphable. Okay? Any questions about how we got this equivalent equation? Okay. We'll do the same thing in number 4. Right? This 3 in front of that x makes me not able to graph it. So let's make an equivalent equation. Okay? So we still have this 2 in front of the absolute value. Absolute value of. You factor out whatever is your coefficient on x. So in this case, it would be a 3. Divide both of those things by 3, leaving you with x plus 3. Now that you have a product inside your absolute value, you can say that's going to be 2 times the absolute value of 3 times the absolute value of x plus 3. Okay, now the absolute value of 3 is 3, right? 2 times 3 is 6. So an equivalent expression would be 6 times the absolute value of x plus 3. So that would be our equivalent equation. F of x equals 6 absolute value x plus 3. So this one would be shifted left 3 and vertically stretched by 6, so up 6 over 1, and that's the only point we can plot there. Okay, now I want to do something else with this one. Okay? I mean, I could have done it with all of them, but I'm going to prove that point with this one. Let's say I want to write it as 2 lines. I'm going to do that down here. So as a piecewise function of 2 lines. Okay, I want to write this a different way. F of x would equal on the right side it would be what's the slope and what's, well, we'd have to figure out what's the slope and what's the y-intercept. Well, the slope is 6. What's the y-intercept of this part of the line, though? What do you think it would be? Because I don't see it here. Like if I'm looking at just, ooh, someone said it. 18. 18. Yes. How do you know it's 18?
Because, like, as you move, so it goes up by 6, and you have 3 x's, so it goes up 6 3 times.
Exactly. Go up 6 3 times, yeah. And you could also look at it as, it's a line, right? So it would be this. And if you distribute the 6, it would make 18. So the first line would be f of x equals 6x plus 18 for x values that are greater than or equal to what? Negative 3, because that's where the vertex is, right? Okay. Now let's think about what the other line is. The other line has a slope of negative 6. And what do we think that y-intercept is? Negative 18. Because it would be negative 6 times x plus 3. So this would be negative 6x minus 18. And that's for x's that are less than negative 3. So we just wrote, this is the absolute value function, and this is the piecewise graph if we look at it as 2 lines. Okay? No, because what this little brace, this is not a solution set. This notation is for a piecewise function that tells you, like, this function f of x is all of this stuff. Because you could have a piecewise function that's a little bit of a line, a little bit of a quadratic, all paced together, and it would have like a list of all the things. Okay? You have a homework question that asks you to take one of these functions and write it like this. All you got to do is figure out what's the slope and the y-intercept of each line, each piece of the line, and it changes at the vertex. Okay? If we have time, I'll make up one and we can do one, but we'll see. Okay, example 5. Look at that one closely. Well,
it's negative 1. The
yeah, a is negative 1.
And then the 3 should be at the end. It's plus 3.
Right. This 3 should be this 3 is a k. We need to kick it back to where it goes. 3 minus this absolute value. We could write this equivalently as negative, or I'm sorry, I need to put my f of x first. F of x equals negative absolute value x plus 1 plus 3. Plus 3 because that 3 is positive. The negative is the negative 1 that's attached to our absolute value. Okay, so sometimes your k sneaks up front, kick it to the back. Okay? Okay, so let's make that graph. Where are we going here? Shifted left 1.
Wait, how do you know you're not multiplying?
Because if I was multiplying, it would be 3 times absolute value. Because look at this. I could have like 3 minus 2 or 3 times 2, right? They're different things. It's just that instead of the number 2, I have an absolute value. 3 minus 1 absolute value of x plus 1. So it would be left 1. So this one's shifted left 1 up 3. So left 1 up 3. But that minus sign, remember when a is negative, that's a reflection over the x-axis, right? So that v isn't going to be pointed up. It's going to be pointed down. So I'm just going to make a note here. This is a reflection over the x-axis. Or in other words, we're just going to graph a slope on the right side of negative 1. So down 1, right 1. So our essentially the first slope is negative 1. And then to make that v have a slope of positive 1 on the other side. Okay. Yeah, so always plot your vertex first. Your vertex is determined by the shifts, the h and the k. Because, I mean, honestly, the vertex of all of these functions are h comma k, right? Like the vertex here is negative 1, 3, because h is always opposite what it looks like. So you get your vertex first, and then this is a slope. Okay. Okay, domain, we know that's never changing, right? But the range, the fact that this tips over is reflected, it changes what we would consider the range to be, right? So if I look bottom to top, the very bottom is negative infinity, and the top is 3. So parentheses, negative infinity, 3, bracket. Okay? Because the bottom is going to negative infinity and the top is 3. So that means, does this one have a min or a max? This one has a max, and its maximum is 3. Okay? All right. How we feel about that? Great. Practice. I mean, you know, practice, right? All right. For this last one, all we're going to do is do the equivalent equation. We're not going to graph it, nothing else, okay? Because this one is interesting, to say the least, right? You got a fraction as your coefficient on x. So to make your equivalent equation, what do you have to do with the coefficient on x? Well, you're factoring it out, right? So I'm going to factor out the 1/3. So you're essentially going to divide it by every term inside the absolute value. So 1/3 x divided by 1/3 is just x. Now here's the tricky part. Negative 2 divided by 1/3.
6. No, this is divided by.
Negative 2 divided by 1/3. Negative 6. Because how do you multiply fractions? Or I'm sorry, divide fractions. You multiply by the reciprocal. So it would be negative 6. So this would be 1/3 times x minus 6. And I mean, look, this makes sense. If you were to distribute 1/3 into the stuff in parentheses, wouldn't you get 1/3 x minus 2? I mean, yeah, right? It makes sense. You gotta, right? You can always check yourself. Does that make sense if I distribute that? You know? So since we have a product, I got that 9, I keep writing. I can split it up, so 9 times the absolute value of 1/3 times the absolute value of x minus 6 plus 1. Absolute value of 1/3 is 1/3. What's 9 times a third? 3. 3 absolute value of x minus 6 plus 1. Can't forget my f of x. Okay?
Could you, like, in theory, distribute the 9 and then, like, factor it back out?
Well, you can't distribute over absolute value symbols. You would have to be mathematically correct, you'd have to do it this way. You'd have to split it up into 2 lines. Because this is not anything you can distribute over. So I'd have to write it as 9 times 1/3 x minus 2 plus 1 and negative 9 times 1/3 x.
Okay, yeah,
and then I could do that. But I see what you're saying, because yeah, it would make a 3, right?
Yeah.
But I couldn't. You can't break into the wall, basically. Okay.